We're going to start talking about functions, which will be the first example of code abstraction. And by code abstraction, I mean writing a code that can be used generally or in multiple applications instead of a single task or position like the code snippets we've worked on so far. So first we'll talk about functions, what the components of a function are, and just mention some of the further topics that will be coming up later in the class when we talk about functional programming paradigms. Okay, so we haven't defined functions, although we did have some examples of it in the homework where you were adding lines to functions. But without having formally talked about how you define functions, we've used many of them. So length is a function that returns the length of a sequence. Type is a function that returns what type of object a particular variable refers to. Raw input is a function that returns a string typed in by a user. Math.square root is a function that returns the square root of a real number. And as we mentioned previously, there are the differentiation between functions that are available in the Python core versus functions that are available in modules or libraries. So length, type, open are example functions that are defined in the Python core. That is, as soon as you start Python, these functions are available to you. By contrast, square root is a function that is defined in the module math. Now this comes with Python, but it's not immediately available to you, so you have to import it, which is an analogy I used in class. Is you're checking out this book from the library and adding it to your library at home that you already had access to. So what do all of these functions have in common? Well, they're all invoked by typing the function name, for example, length, followed by parentheses. And then within the parentheses, you have any required or optional arguments. And as we'll discuss, you may not have to provide any arguments. And as just kind of a note, functions in Python always return a value. And if I don't specify what is returned, Python will by default return a value of none. Okay, so what is a function? So if we turn to the dictionary, so Merriam-Webster defines a function as any of a group of related actions contributed to a larger action, especially the normal and specific contribution of a bodily part to the economy of a living organism. Or a computer subroutine, specifically one that performs a calculation with variables provided by a program and supplies the program with a single result. So I think thinking about it in both ways is useful. So if you think about the body's composed of a number of organ systems. So take the lungs. So the lungs take as input air from the surrounding. And then I guess you can look at it in two ways. The output is oxygen into the blood, or carbon dioxide out of the lungs. And that's combined with another organ system, the cardiovascular system, whose function is to take blood from the venous system as input. If we think about the right heart, as output is blood to the pulmonary arteries, and then as the left heart takes as input blood from the pulmonary veins, and as output blood to the systemic arteries. So it takes something in and maybe manipulates it, adds oxygen, whatever, and then puts something out. So why do we want to use functions? Well, I think that there's two primary reasons. First is code reuse. So if I want to write a function that reads in some representation of a patient, I write that code once, I debug it, there's going to be problems the first time I write it, so I debug it, I fix the problems, I document it, and now I can use that same function many times. I don't have to rewrite that every time I have a program that wants to have the functionality of reading in a patient representation. So this makes upkeep and modifications of the code much simpler. The second reason is procedural decomposition. Programs as we write them will become very complex, doing many things. And what we want to do is we want to be able to break those many things into small units. And so this is what I'm referring to as procedural decomposition. That is, a function should do one thing, not multiple things. And so if I get down to what's the basic step I want to manipulate on some piece of data, that's what's going to define my function. So a friend of mine from graduate school who unfortunately passed away, and there is a Mark Thomason Memorial Fund here at the University of Utah. He said an entire function should be visible on your screen within your editor. So that was kind of his rule, to make sure that a single function didn't get too large and complex and try to do too many things. Of course, he did have the caveat: if your function doesn't fit on your screen, just buy a larger screen. So functions are an example of compound Python statements like the if statement, the for statement, the while statement. So this is how we define a Python function. We start with the keyword def. So this stands for definition. So a definition is following. Definition of a function is following. We provide some function name, and these brackets just mean that, replace this with your own code. The brackets are not part of the function name. And we have an open parenthesis. We have an optional list of arguments. I'm going to get rid of that extra comma, and then the colon, which marks the beginning of the code block. We have an optional docstring, which we'll talk about, and then we have the statements that constitute the body of the function. These are the Python statements that are going to do the manipulation or execution of what we want this function to do. Okay, so let's go over each of these in more detail. So def, not much more to say than that. It's a reserved Python word, and it marks the beginning of the function definition. Okay, the function name is the name you're going to give to your function. For example, hello world, raw input, square root. Okay, then the args are the arguments of the function. So if we think about mathematical operations, let's say the cosine function. In this case, cosine is the function. Pi over 4 is the argument for the function. Oh, I got another typo here. Fix that. Pi over 4. So Python functions can have 0 or more arguments. So I can define a function that does not have any arguments. I can also define functions that have a variable number of arguments, and we won't talk about that today. So function naming in Python is flexible, but there are essentially one rule that has to follow. The name of the function must either start with a letter or start with the underscore character. You should use names that describe what the function does. That is, try to avoid things like F1, F2, Func1, Func2, but instead have names like get patient demographics, normalize the data, etc. There's lots of naming styles around. for instance, there's camel case, where you start with a lowercase word, and then you're concatenating the words. And so whenever you start a new word within the name, you use an uppercase. So I use this a lot, but it is discouraged for functions in Python according to Python style guides. So the preferred method is to combine words for your function name by keeping the words lowercase and combining them with an underscore. And here's just an excerpt from the Python style guide. Okay, so by hiding functions, this means that if I use an existing name, for example, print or length for my function name, my new function name will hide the built-in function. That is, I will no longer have access to the functions in my program. And that's within the caveat of the scope of the namespace, which is a detail we'll pick up on later. So here, if I get a Python shell and define the following function, def length, I pass it an argument n, and now what I'm going to do is this function now returns n times n. So if I have typed this into a shell and I then call this function length with the string Brian, what is the function going to do? Well, in the case of Brian, I'm going to get, let me just make sure I don't have it on the next. Okay, so I have it here. So what do you think is going to happen? So when we talked about strings, we didn't have any context. We didn't mention anything about a string times a string. And in fact, when we evaluate this, we get an error that says, a type error. You can't multiply a sequence by a non-integer of type string. So it makes no sense to multiply a string by a string. Let me change this now to, okay, so we define this as length 1. If I come in here before doing that and I print length of Brian, I get a 5, so the length is functioning as it should. But now let me change this name to length. And now, as soon as it's called, this is what's getting called, and I'm getting that same error of we can't multiply a sequence by a non-integer of type string. So I've now lost access to the built-in function length in Python. Hopefully I won't need that for the rest of this lecture. I can get it back by resetting my kernel. Okay, so then, after we have the definition and the function name, the function definition requires that we have parentheses. So all function definitions include parentheses. And the parentheses contain the arguments, what goes into the function, which I'm denoting by arg1, arg2, and so on. As I said, a function does not have to take any arguments, but it does have to provide the parentheses. And the colon marks the beginning of the code block constituting the function. Okay, so function arguments. We can pass arguments to functions in a variety of ways, of which we will talk about 2. The first are positional arguments. And so this would be the example of function arg1, arg2. These arguments must be provided and provided in the order specified in the function definition. A more flexible way is through keyword arguments. And these are invoked in this way, where I have my function, and then I have the variable name that I'm passing in as an argument. These will be the variable names in the function. So I have a variable name, my name, and then I do an equals, and then I provide what is a default value. So in this case, the default value of the variable my name is Brian, and the default value of the variable your name is Wendy. So if I don't provide this keyword argument when I call func2, the default value is used by the function. And then you can provide variable length positional arguments, so we're not going to talk about it this time. Okay, so a little more detail on positional arguments. Here's the link to the documentation on it. So first number, second number, favorite letter, these are ordinal positional arguments that must be provided. When I invoke my function, I have to provide first number, I have to provide second number, I have to provide favorite letter, and they have to be provided in that order. Okay, here we have my function 2, where I'm providing my age, the default value of 29, and skis equal Rossignol. Now the order of these arguments does not matter. I can call it first with skis and later with my age. I can call it without providing either of these functions, and Python will use these default values that are provided in the definition. Okay, I'm going to, let's see, I'm just going to I'm going to insert a, right here, I'm going to insert the code cell below, call this a subslide. Okay, come on, don't hide this. Don't hide it from me. Okay, so let's just do this by function 2. A bad function name, but there's no real meaning to this. And what I'll do is I'll just print these things. I'll say my age is okay, so then I can call this my function 2. If I don't provide any arguments to the function, when I evoke this, it's already going to do the print statement, sorry. You see, I didn't provide 29 or Rossignol, but it uses those. So then what if I provide my function 2? Now in this case, it used my age is 46, but kept the default ski. Okay, so it's taken what I've provided there, and the order that I do those doesn't matter. Okay, let's go back to the code where we were. Okay, so if I pass a variable to a function, can that function modify the variable that I passed in? The variable being passed in having is referred to as the argument. So immutable parameters cannot be modified in a function. So if I pass a string, that string is not changed by the function. But a mutable parameter, such as a list, can be modified by the function. In general, the preferred Python programming style is that you do not modify parameters within the function. And this becomes very important in functional programming, which will be an important topic for like parallel programming. But the point is, you can modify mutable parameters, arguments, and sometimes that's a convenience you want to exploit, but oftentimes it'll have unintended consequences for you. Okay, I did mention that the function definitions, immediately after the function definition and the colon, that you can have what is referred to as a docstring. So this is a string of text describing the function that you provide immediately after the declaration. When you're using the help function or the question mark in IPython, what those functions do is they return the docstring that has been defined by the author for that function. So docstring is not required, but is generally desirable. And it provides you the opportunity to define what the arguments mean, what types you're expecting in the function, etc. It also explains what the function returns. So here's an example of a function definition. So I have docstring demo. So here I'm providing the docstring. It says this is the docstring for the function docstring demo. Docstring demo doesn't take any arguments, doesn't do anything interesting, and only returns done. So and it returns, I'm not providing anything, it's just, so it's returning a none here. But when I invoke the help function, it's returning that string for me. So this is very useful for discovering how functions that other people have written, and also helpful for you for documenting the purposes of your own functions. Okay, following the docstring are the program statements. These are the code block of Python statements that are going to constitute the body of the function. They're going to do what you want that function to do. And those code blocks are part of the function until the indentation of the Python statements returns to the level of the line with the def statement. You do have to have an indented block, but your function can do nothing, and you get your function to do nothing by either a pass statement or a return statement. Okay, so here's a definition of a function which takes in a number, and it's going to return a 1. So a body of the statement is I'm creating a variable b and assigning to it the value that's in a number, but then I have the return 1 statement, and then I have a print statement. So this is all the body of the function. There's 3 Python statements. Now, as I mentioned here, this statement will never be arrived at, even though it's part of the function, because the function will return. That is, you're leaving the function and you're returning the value 1 to the program that called this function. And so this is never reached. So here's another function where I take in a string, reverse and capitalize. I take in a string. I have my docstring for it. I create a new string, temp string, which is the string that's passed in, converted to uppercase. And then I take that string and I reverse it, and this is what I'm going to return. So if I add in, let's see, string, reverse, and capitalize, I pass in like Brian Chapman. Let's see our results. So here when I called function 1, I pass to the value 4. What I get is 1. And here I'm calling string reverse capitalize. I pass in Brian Chapman, and it returns capitalize and reversed. Okay, here's a function 3, which takes in an argument and multiplies it and then returns it. And this is just to demonstrate that I have this variable a, and when I call it, I've created a variable b. See here, A will come in as 5, and then it will be assigned the value of 15. So let's look at what B is back in the calling function. Is it going to be 15 or 5? Okay, it's 5 because we didn't actually, what we did is we passed a copy of the variable B to the function, and so the original B in the calling code remains unchanged. Okay, something that a lot of people get confused on is that the variable names in the function definition, for example A, do not correspond to the variable names when the function is called, for example B. It's kind of like, they're not the same thing. And so we can name the variables anything we want in the function that are independent of what the variable names are when we're going to be calling the function. And this is a point that people oftentimes get confused on. Okay, and that brings up the concept of scope. And scope is where are these names defined? Where are these variables defined? And so you have local and global scope. So local name hides global names. And the parameter names have no relationships to argument names and function calls. So here, it's just a demonstration of that. In this global scope here, I've imported the module math, and I've created a variable e, which is equal to Euler's number, math.e. I'm going to print that value out, and now I'm defining a function 4. In function 4, I define a variable e as equal to d minus 3, and I'm going to print out what the value of that is, and then I'm going to return it. And when I return it here, as I invoke function 4, I'm going to assign it to the variable f. Okay, so let's evaluate this cell. Okay, here my first statement, print e is, so this is the value of e that was imported from the math library module, 2.71828, blah, 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 blah. Okay, now I invoke my function 4, so I've passed in 5 and I'm subtracting 3. So here in the function I have a variable e, and I'm printing out what its value is. Its value is 2. So you see that this e is hiding the value of e in the global space. So I've returned that value and I've assigned it to the variable f here in the global space. And so I'm printing that f has the value of 2. And now I'm going to print the value of the variable d, which was used here in the function, and I get a name error. There's no variable, there's no name d in this space because d has meaning only inside of this function. It doesn't have any meaning outside of that function. So that's an illustration of the local scope of variables in a function. Okay, so let's do a couple of example functions. So let's create a function that returns the value true if a uniform random variable is less than the function argument b. And then we return an error message if b is not in the range 0 to 1. Okay, so this function that I'm going to write is going to have a bad functional style, and that the type that's going to be returned is going to vary by the path that the code executes. So in one case I'm returning a true or false, and in another case I'm returning a string. And so we're not going to talk about exceptions right now, but that will create a better approach to solving this problem. So I import the module random. I define this function using the non-preferred camel case style, less than random. I provide my docstring. So now first off I test whether x is less than 0 or greater than 1. And if it is, then I return the string that x must be between 0 and 1. else I'm going to return the Boolean value that results from my comparison of x that was passed in and the random number that's generated. Okay, so let's run this, enter a number between 0 and 5, 0 and 1, so in that case it's false. If I enter in a 6, I get the string message. In that case, it evaluates as true. Okay, now let's write a Python function for the following mathematical function. That f of x will return the value e to the a times x minus b if x is less than b. Otherwise, the function will return 0. So I import math. I have my math function. I'm going to use a positional argument x, and then I'm going to have keyword arguments a and b. So I have my first condition. If x is greater than or equal to b, I'm going to return 0. That was part of my function definition. Else, I'm going to return the exponent of a times x minus b. And then let me call it with math function minus 3. It returns that value. I can provide values for b. Okay. So there's a lot more to learn about functions. These will be expanded upon as we go out throughout the semester. But all these functions, lambda is a way of defining generic functions. Map, filter, and reduce are kind of functional programming tools that will be useful paradigm as we try to make our programs use the multiple processing capabilities of modern computers.